At the farthest, coldest edge of our solar system, in a region so remote that sunlight has faded to a pale whisper, a new cosmic enigma has burst into the spotlight. Astronomers have unearthed a celestial relic so rare, so utterly mysterious, that even the world's most seasoned scientists are questioning everything they believed about our planetary neighborhood. Imagine this. An ancient wanderer, predating any known human civilization, quietly journeying for eons through the perpetual darkness beyond Neptune's distant orbit. Its path through space is so bizarre, its orbit so hauntingly unique, that it challenges every expectation. Could this new discovery be the missing link to the origins of our solar system? Or does it hint at a cosmic secret, a riddle etched in the darkness, that humanity was never meant to solve? To truly grasp the magnitude of this breakthrough, let's journey back in time. For decades, astronomers have been mapping the frozen frontier that lies beyond Neptune, a vast, ghostly expanse called the Kuiper Belt. This celestial graveyard stretches for billions of kilometers, populated by icy bodies, dwarf planets, and comet-like fragments, all drifting in an endless twilight. These objects aren't merely remnants, they are time capsules, preserving the raw, primordial materials from which our solar system was forged more than 4.5 billion years ago. Each body holds stories of the chaos and creativity of planetary birth, and together, they act as a fossil record of early solar history. Within this icy wilderness, a handful of objects stand out: sednoids. They form an exclusive club of cosmic wanderers, each with orbits so stretched and so distant that they seem almost cut loose from the sun's influence. Before this latest revelation, only 3 such objects were known: Sedna, Lilia Kuhonua, and a mysterious celestial body known as 202VP. Each of these sednoids shares bizarre orbital features. Their paths are elongated, carrying them hundreds of times farther from the sun than the Earth ever travels. Even more strangely, their orbits seem to cluster together, as though sculpted by an unseen force lurking in the void, invisible to even our most powerful telescopes. But now, a 4th sednoid has emerged from the cosmic shadows, and its existence is nothing short of revolutionary. Meet Ammonite, officially catalogued as 2023KQ14, a name that may one day join Pluto and Uranus in the pantheon of planetary legends. The discovery of Ammonite was made possible by the ambitious, multinational fossil project, which harnessed the power of the Subaru telescope atop the volcanic summit of Mauna Kea in Hawaii, and delved into nearly 20 years of forgotten astronomical data. This is no ordinary cosmic pebble. Ammonite is a mid-sized object, with a diameter estimated between 220 and 380 kilometers, making it roughly 40 times the height of Mount Everest, the tallest mountain on Earth. To help visualize this, imagine stacking Mount Everest on itself 40 times. You would still fall short of Ammonite's immense width. Yet size is only the beginning of Ammonite's extraordinary story. Its orbit is truly staggering. Ammonite swings from a closest approach, or perihelion, of about 66 astronomical units from the Sun. To put this into perspective, 1 astronomical unit is the average distance between the Earth and the Sun, around 150 million kilometers. That means Ammonite's closest approach is 66 times farther from the Sun than Earth, a distance so vast that sunlight there is more like a faint memory. At its most distant, or aphelion, Ammonite travels outward to a jaw-dropping 252 astronomical units. Some orbital simulations even suggest its path may stretch as far as 438 astronomical units. Its full journey around the Sun, 1 complete orbit, takes about 4,000 years longer than the span of all recorded human history. Imagine an object tracing a vast, spiral, fossil-like loop at the very edge of existence, untouched and unchanged for billions of years. What truly sets Ammonite apart, however, is not just its remoteness or ancient stability. It is the peculiar shape and orientation of its orbit. Unlike its sednoid siblings, whose orbits seem to cluster in a particular direction, Ammonite's path is anti-aligned. In simpler terms, it moves in the opposite direction, tracing a spiral that stands apart from the rest. This oddball trajectory has sent shockwaves through the astronomical community. For years, one leading theory in planetary science held that a massive, hidden planet, nicknamed Planet 9, was lurking in the darkness far beyond Neptune. According to this hypothesis, Planet 9's immense gravitational pull would herd the sednoids into neat, clustered orbits, like sheep guided by a distant shepherd. The orbits of Sedna, Leleikuhonua, and 202 VP seem to fit this pattern, all pointing in a similar direction. But the discovery of Ammonite has disrupted this neat arrangement, as Dr. Yukun Huang from the National Astronomical Observatory of Japan explains. The fact that 2023 KQ-14's current orbit does not align with those of the other three sednoids lowers the likelihood of the Planet 9 hypothesis. In other words, Ammonite's existence may be the key that unlocks a far more intricate, perhaps even more chaotic, history of our solar system. So what could have sent Ammonite on its rebellious, unique journey? The answers are as tantalizing as they are mysterious. Some astrophysicists suggest that a dramatic event in the distant past, a near-miss encounter with a rogue star, could have shaken up the outer solar system, flinging objects like Ammonite onto wild, unpredictable paths. Such a stellar flyby, occurring when our sun was still young and nestled within its birth cluster, could have gravitationally jostled the fragile outskirts of the solar system, sculpting the peculiar orbits we observe today. Others theorize about vanished planets, giant worlds that once roamed the outer reaches, only to be ejected or destroyed, leaving behind a scattered population of sednoids as their ghostly legacy. There are even suggestions that a collection of smaller, undetected objects, or distant stellar remnants, is subtly shaping the orbits of these bodies, hinting at layers of complexity we have yet to fully unravel. Dr. Fumi Yoshida, also of the National Astronomical Observatory of Japan, underscores the significance of this research. Understanding the orbital evolution and physical properties of these unique, distant objects is crucial for grasping the full history of the solar system. Sednoids like Ammonite may harbor pristine samples of the primordial material from which planets, moons, and comets were born. By studying their surfaces, rich in organic compounds and volatile ices, scientists can glean clues about the chemistry and environmental conditions that prevailed in the outer solar system billions of years ago, at a time when life on Earth itself was only just beginning. The implications of Ammonite's discovery are profound and far-reaching. If Ammonite is indeed a time capsule, then its strange orbit is a cosmic fingerprint of ancient chaos. It may be evidence that the solar system's youth was far more tumultuous than previously believed, shaped by cosmic accidents and gravitational encounters that left permanent scars. Astronomers now face a puzzle of cosmic proportions. If Planet 9 cannot account for the oddities of Ammonite's orbit, then what hidden forces have been sculpting these distant worlds for more than 4 billion years? Could we be on the brink of discovering an entirely new class of objects? Or is there a population of rogue planets or ancient stellar remnants lurking at unimaginable distances, silently molding the architecture of our cosmic neighborhood? The discovery of Ammonite opens multiple doors, each leading to a different vision of our solar system's past and future. If more objects like Ammonite are found, each with similarly strange orbits, it could force astronomers to rewrite the textbooks about how planets form and migrate. The stakes are high. Every new discovery has the potential to strengthen or topple existing theories. In the coming years, wide-field surveys, such as the Fossil Project, the Vera C. Rubin Observatory, and even space-based missions, could unearth dozens or even hundreds of new sednoids. Each one is a cosmic detective story waiting to be told. But you might be wondering, why does this matter to us as inhabitants of Earth? Whether you are watching from a city lit by millions of electric lights or gazing up from the quiet darkness of the countryside, the lesson is profound. Ammonite reminds us that the universe is not a closed book. Every time we believe we have mapped the basics, the cosmos surprises us with new riddles and challenges. For students, researchers, and anyone fascinated by the unknown, this discovery is a clarion call to curiosity, a reminder that even in the 21st century, uncharted frontiers remain. The outer solar system, once dismissed as a static, frozen wasteland, has become a vibrant laboratory for testing the boundaries of our scientific understanding. Let's take a deeper look at what makes sednoids like Ammonite so extraordinary. These objects are not simply distant. They are survivors of cosmic upheaval. Their orbits are so elongated that, for most of their journey, they remain beyond the disruptive gravitational grasp of Neptune, the last of the giant planets. This means that, for billions of years, they have been largely untouched by the processes that shaped the main planets. Some scientists believe that sednoids may preserve the most primitive material in the solar system. Their surfaces, coated with organic compounds and frozen ices, offer a unique window into the chemistry that prevailed in the earliest days of planetary formation. By analyzing the spectral fingerprints of these compounds, astronomers can reconstruct the recipes that gave birth to planets, moons, and perhaps even the seeds of life itself. But the story of Ammonite goes even deeper. Its discovery was made possible not just by cutting-edge technology, but by the tireless dedication of scientists who combed through nearly 2 decades of archival telescope data. This painstaking work highlights the value of persistence and the importance of re-examining old observations with new tools. Hidden wonders may be waiting in forgotten files right now, each one a clue to a greater cosmic story. As the Fossil Project demonstrates, sometimes the greatest breakthroughs emerge not from new telescopes or billion-dollar missions, but from the careful reanalysis of data already in our hands. The message is clear. Sometimes the future of discovery lies in the past. Let's zoom out to view the broader landscape. The debate over Planet 9 has raged for nearly a decade. When astronomers first noticed the clustered orbits of Sedna and its kin, the simplest explanation was a massive, unseen planet, perhaps 10 times the mass of the Earth, orbiting far beyond Neptune. This hypothetical world, known as Planet 9, captured the public's imagination. It echoed the 19th century tale of Neptune's prediction, when astronomers noticed the wobbles of Uranus and deduced Neptune's presence purely from mathematics. In that era, the discovery of a new planet revolutionized our view of the cosmos. But Ammonite's anti-aligned orbit and its ability to fill a previously unexplained gap in the distribution of distant objects weakens the case for a single, shepherding planet. Instead, the evidence now points to a more intricate tapestry of cosmic events. Perhaps the outer solar system is shaped not by one secret giant, but by a multitude of smaller influences, passing stars, rogue planets, and even the collective gravity of countless unseen bodies. As Dr. Yukun Huang notes, Ammonite's orbit lowers the likelihood of a simple explanation. It challenges us to embrace a more complex, dynamic history for our solar system. This underscores a broader truth in science. The universe is rarely as simple as we wish, and every new discovery only deepens the mystery. To better understand the significance of this, consider the formation of our own solar system. Billions of years ago, our sun was born in a crowded stellar nursery. There, the young sun and its siblings drifted close to one another, their gravity tugging and pulling on each other's nascent planetary systems. A single close encounter, a flyby of a passing star, could have sent shockwaves through the outer solar system, stirring up orbits and flinging material outward. Astronomers now believe that such events were more common than once thought, and Ammonite's orbit may be the lingering fingerprint of such ancient chaos. There are fascinating historical parallels to this cosmic detective work. In the 19th century, astronomers inferred the existence of Neptune by noticing unexplained deviations in Uranus's orbit. Today, we are once again following clues, this time in the cold, distant realm beyond Neptune. But where Neptune's discovery brought closure, Ammonite's odd orbit opens new questions. Are there invisible worlds yet to be found? Or are we witnessing the subtle effects of long-lost stellar encounters? Could there have been entire planets that once roamed the outer solar system, now lost to interstellar space, leaving only their gravitational fingerprints behind? Looking ahead, the search for answers is just beginning. New telescopes, equipped with ultra-sensitive cameras and wide-field detectors, are poised to scan the heavens for more hidden worlds. The Vera C. Rubin Observatory, with its unprecedented ability to survey the entire sky, is expected to revolutionize our understanding of the outer solar system in the next few years. By tracking the orbits of dozens, or even hundreds, of sednoids, astronomers hope to reconstruct the true architecture of our planetary neighborhood. Will we find evidence of a long-lost planet? Or will the fingerprints of ancient stellar encounters become undeniable? Beyond planetary science, there are even broader implications. Studying distant objects like Ammonite may help us understand how planetary systems form around other stars. The ices and organic compounds found on sednoids could mirror the chemistry within protoplanetary disks, the swirling clouds of gas and dust that give birth to new worlds. By decoding Ammonite's secrets, we may one day recognize the fingerprints of life-supporting chemistry on exoplanets orbiting distant suns. In this way, the study of our own backyard becomes a roadmap for exploring the universe at large. Let's not overlook the philosophical side of this discovery. Ammonite is a humbling reminder of our place in the cosmos. For centuries, humanity has gazed at the night sky, searching for meaning in the movements of planets and stars. Each new discovery, each strange orbit, each cosmic outlier challenges our assumptions and forces us to reconsider the limits of our knowledge. The outer solar system, once thought to be a frozen wasteland, is now a frontier of discovery, a reminder that the universe is alive with mystery and possibility. So what really shaped Ammonite's journey? The evidence suggests that there is no single answer, and Ammonite's orbit tells the story of a solar system forged in chaos, a realm where stellar drive-bys, vanished giants, and the relentless dance of gravity have sculpted the architecture of the planets. Its existence is a testament to the unpredictable, ever-changing nature of the cosmos, where every answer breeds new questions. As we close this chapter, remember that discoveries like Ammonite are not just the domain of professional astronomers. Citizen scientists, amateur stargazers, and curious minds everywhere have a role to play. With every new sky survey, every fresh analysis of old data, the next cosmic secret could be within reach. If you found this journey to the outer solar system as eye-opening as we did, don't forget to subscribe for more deep dives into the mysteries that shape our universe. What do you think happened at the dawn of the solar system? Could there be more Ammonites out there, waiting to be found? Share your theories and questions in the comments.